Is positioned 10 meters from the sidewalk. A person is walking along the sidewalk at a constant speed of 2 meters per second. The searchlight rotates so that it shines on the person. Find the rate at which the searchlight rotates when the person is 25 meters from the searchlight.
So let's start with the horizontal line, because the person is walking horizontally. And I think I want to draw the person on the right side. If the searchlight is basically shining at them, it's going to be somewhere on the top. And then make a vertical line. And here's my hypotenuse. It says the person is 25 meters from the searchlight. So let's say this is a light. And I'm going to call that theta. 25 is going to be my hypotenuse. This light to the sidewalk is 10 meters. If y'all remember from geometry, the distance is always perpendicular. It's always the shortest distance. So I'm going to call this A as in the altitude. C should be our typical hypotenuse. And let's call B as in the base. So let's go ahead and write out our Fuigi. So it says to find the rate it is rotating. So we're looking for d theta over dt. And they already gave us a when piece, right? When we are 25 meters from the searchlight. I think we have two when pieces. We have the A value is 10 meters. And then the C value is 25 meters. Or if you want to draw the arrow and say, hey, look at my picture. That works out too. The given rate. What is a given rate? A person is walking what? 2 meters per second. The person is going to go horizontally. That's going to be dB over dt. So 2 meters per second. And then I want to kind of discuss something. The distance from the light to the sidewalk, is that going to change? No. So that means dA over dt is going to be 0. If you write meters per second, you can as well. I'm running out of room again. Great.
Wait, could you explain why you got that?
This right here
Yeah.
is the rate of this changing? No. So therefore it's 0. Okay? So because I have dB over dt and dA over dt, I want to focus on the ratio of tangent. So we have tangent theta is equal to the opposite, the B over the A. That construction noise is being recorded. Okay. All right, let's use Pythagorean and find out what the B piece is. So 25 squared minus 10 squared, and that's going to go in the square root. 525 inside the square root. So let's write out the equation. So we have tan theta is equal to B over A. And we are going to derive this with respect to t. What is the derivative of tangent? Secant squared. And then for every single variable, I have to say d whatever over dt. So this one was d theta over dt. And then we're using quotient rule on the right side. Quotient rule states, take my bottom and square it. What is the derivative of 1b? 1. So it'll be dB over dt minus b, oh, I forgot the a. Thank you. Times a minus, we keep the top. Derivative of 1a is 1 and dA over dt. So let's plug everything in that I know. The secant is hypotenuse over the adjacent, right? We already know hypotenuse over the adjacent. So let's write on here we have 25 over 10 squared. And we're looking for d theta over dt, so that's going to be the variable. And we know dB over dt is how many? 2. We know the a value is how many? 10. A is 10. Minus, my b value is radical, I can't fit all this right now, 525. But since dA over dt is 0, do I really need this? Nope. Divided by 10 squared. So let's do some simplifying using algebra. I think I'm going to take this guy right here, 20 over 100. That's the right side. Do we all see that? 20 over 100? And I'm going to take that number and divide it by 25 over 10 all squared. I feel like I need parentheses. Just going to fit it in just in case. All squared. And that's going to give us the rate of the angle is at 4 over 125. And it's in radians per second because we're looking for the theta. Let me move all this.